Let's talk about the different types of machine learning models and how you can know which one to choose. There are many types of machine learning models, but not every one works for every problem. So to break it down, start by naming the problem you're actually trying to solve. If your goal is to predict a number, you're going to start with probably the simplest machine learning model that's out there, linear regression. Essentially, it makes a line of best fit through your data, so it's super simple to see what output any given input would result in. Now I want you to check your errors or residuals. If they're randomly bouncing around, then you're probably in good shape. However, if they form a systematic pattern, for example, the prediction is too high for low values but too low for high values, then your straight line model is too simple. This means you need to add nonlinear features, which are new columns you can add to your dataset to make the model more complex. You can use the ridge model when you have a lot of features that just matter a little bit, but the lasso feature when you have a smaller set of important features. Next, if your target is to predict a category, you're doing classification. A good first step depends on how many classes you have. For just 2 classes, go with logistic regression, but if you have more than that, try decision tree. Logistic regression models a weighted linear combination of all your features to produce probabilities for each class, while decision trees continuously and iteratively split the data with simple rules to assign a class. If your accuracy stalls, this is where you need to start ensembling your model, so level up to a gradient boost model or a random forest. Naive Bayes is also a great super fast classifier that works great on high dimensional data. Its simple independence assumption can miss interactions between features, so definitely treat it as a strong baseline. Now, if your goal is to find natural groups within a dataset, then you're clustering. The obvious model here is k-means clustering, and it's great for when your data doesn't have labels and you want it to organize itself. However, if you expect your clusters to be weirdly shaped or you have data with a lot of noise, I would consider trying out the dbScan model. In contrast to k-means clustering, which is a centroid-based clustering algorithm, dbScan is a density-based clustering algorithm and is great for finding clusters with weird shapes and identifying outliers. If your goal is to spot weird points within your data, then you're doing anomaly detection. Think of it like this. A z-score tells you how many standard deviation a value is away from the average, and very high or very low z-scores are suspicious. Then the interquartile range rule uses the spread of the middle 50% of the data and flags points that fall far outside that range. An isolation forest kind of goes through this process of using many different strategies to identify points that it should be cautious of and potentially identify them as anomalies. A one-class support vector machine can also detect anomalies pretty well by learning a tight boundary around the normal data and flagging points that fall outside of it. Now, if your goal is to forecast the future, for example, predict daily sales or what the weather will be at 1 p.m., you need to do a time series. Start by building a very simple baseline that just repeats some of the last data you know. Next, try exponential smoothing with a profit model. Profit treats your data as a mix of overall trend repeating seasonal patterns and automatically identifies change points where the trend shifts. Then it fits this with a robust regression that's resilient to outliers and produces a forecast. If your goal is to decide something over time, you're doing reinforcement learning. Think of reinforcement learning as an agent that learns by doing and getting feedback. In the Q-learning model, the agent estimates how good each action will be in each situation. As it keeps learning more, the model gets better and better at what it does. Now for my favorite, deep learning. A reliable way to classify information is to take a strong pre-trained encoder, but this can vary for the type of data you're working with. Use BERT-style for text, a CNN or vision transformer for visual data, and a wave-to-vec style for audio. Feed your input through it and then train a small classifier on top of the encoder's output. The encoder gives you broad, high-quality features that it has learned from a huge dataset, while the small classifier learns the specific yes or no decision for your task. That's a lot of machine learning models, but don't forget to save this video so you can come back to it the next time you're in a rut and follow for more.